Happy August, everyone. I'm your host, Peter Zablocki, and you're listening to another bonus Today in Context episode, where I provide some historical context to things happening in the news. In a recent episode of The Past Weekend with Theo Von, Altman, the CEO of OpenAI and the popular ChatGPT system, said that he got, and I quote, scared while testing GPT-5, likening its development to the Manhattan Project and questioning, what have we done? He highlighted the model's speed and capabilities, expressing concerns about the lack of robust AI governance, stating, "There are no adults in the room." This got me thinking, how did we get here? Where did the fascination with artificial intelligence come from? And after some research, and to my own surprise, it starts in antiquity. But anyway, while I have you here, and before we dive in, make sure you check out today's regularly scheduled conversation episode where I speak with Canadian YouTube sensation Brittlestar about his latest book, Lessons from Cats for Surviving Fascism. This month, I will actually be featuring 2 conversation episodes each weekend. This Sunday, my guest is historian Martin Rady, an authority on the Habsburg Empire and the history of Central Europe. Well, now let's see what this whole AI thing is about.
Yesterday, December 7th, 1941.
It's one small step for man, one giant leap for mankind.
Mr. Gorbachev, tear down this wall.
The earliest known dream of artificial intelligence did not originate in a laboratory, but rather in legend. In Homer's Iliad, the god Hephaestus crafted mechanical assistants who could walk, talk, and help him in his forge. Similarly, the myth of Talos, a bronze giant created to guard the island of Crete, represents an early imagining of an autonomous machine tasked with human-like duties. These tales reflected a blend of awe and unease, a theme that would continue through the ages. In the 3rd century BCE, Greek engineer Ctesibius created water clocks with moving figures, primitive but symbolic mechanical autonoma. Later in the Islamic Golden Age, engineers like Al-Jazari crafted intricate programmable machines, automata shaped like peacocks, servants, and musicians. These were not intelligent by modern standards, but they foreshadowed the core idea that humans could create objects mimicking life. By the European Renaissance, thinkers like Leonardo da Vinci were designing mechanical knights and conceptualizing robotic movement. Yet the philosophical and scientific tools needed to realize true artificial cognition, well, those were still centuries away. The 17th and 18th centuries brought a revolution in rationalism and mathematics that would lay the groundwork for modern AI. In 1642, Blaise Pascal built a mechanical calculator capable of performing arithmetic. Later, Gottfried Wilhelm Leibniz imagined a universal machine that could manipulate symbols in a way that mimicked reasoning. A device that could, in theory, resolve any logical argument. Leibniz's ideas were profound, but they remained conceptual until the 19th century, when British mathematician Charles Babbage designed the analytical engine, a steam-powered, programmable machine. Though never completed, the analytical engine had the essential components of a modern computer: memory, a central processor, and the capacity for conditional logic. Ada Lovelace, Babbage's collaborator, is now recognized as the first computer programmer. She even speculated that machines might one day compose music or create art, a pretty precise vision of AI's future. Still, it was not until the 20th century that a confluence of mathematical theory and wartime necessity accelerated progress toward actual intelligence. The crucible of World War II birthed many of the technologies and theories essential to AI. Alan Turing, a British mathematician and codebreaker, is widely regarded as one of the founding fathers of artificial intelligence. In his seminal 1936 paper, Turing described a theoretical device, the Turing machine, that could simulate the logic of any computer algorithm. This became the conceptual foundation of modern computing. During the war, Turing helped build code-breaking machines at Bletchley Park, which saved countless lives. But it was his post-war work that most directly tackled the concept of machine intelligence. In 1950, Turing proposed what would become known as the Turing test, a way of determining whether a machine can exhibit intelligent behavior indistinguishable from that of a human. Can machines think? He asked. With that provocative question, the field of artificial intelligence took philosophical and scientific form. In 1956, a group of researchers at Dartmouth College, including John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon, convened a now legendary conference. There, McCarthy coined the term artificial intelligence, and the field was formally born. Their ambition was staggering, and I quote, "to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans," end quote. With funding and optimism, the race began. Early progress was swift. Programs like ELIZA, created in 1966 by Joseph Weizenbaum, mimicked human conversation. ELIZA could simulate a psychotherapist, cleverly turning user inputs into open-ended questions. While superficial, ELIZA amazed the public and sparked excitement about the potential of conversational AI. Meanwhile, rule-based systems, or expert systems, emerged, capable of performing specific tasks like solving algebra problems or diagnosing diseases. The logic behind them was straightforward. If X, then Y. Researchers believed that with enough rules, machines could mimic all human reasoning. Programs like Shridlu or SHRDLU could manipulate virtual blocks using natural language commands, suggesting a world of intelligent digital assistants was just around the corner. But enthusiasm outpaced capability. The complexity of human reasoning proved more difficult to replicate than anticipated. Early AI lacked common sense and struggled with ambiguity, nuance, and learning from experience. As funding dried up in the 1970s, AI entered its first winter, you might call it, a period of stagnation and skepticism. But that did not last too long. AI re-emerged in the 1980s with the development of more sophisticated expert systems. Programs like Mycin, designed to diagnose bacterial infections, demonstrated that AI could outperform doctors in narrow domains. Corporations began investing heavily in AI for logistics, finance, and manufacturing. Yet these systems were very brittle. They could not generalize or adopt. Adding new rules often created contradictions or required extensive reprogramming. Moreover, they had no true understanding, only a map of human knowledge. The search was on for a more flexible approach to learning, and researchers began exploring neural networks, models inspired by the structure of the human brain. Although the idea of artificial neural networks dated back to the 40s, it wasn't actually until the 1990s that computing power and data volume allowed them to achieve meaningful results. A neural network consists of layers of artificial neurons that learn patterns through exposure to large datasets. The more data it receives, the more accurate it becomes. This paradigm shift away from rule-based systems and toward machine learning revolutionized AI. Instead of programming every step, developers trained models to learn patterns from examples by itself. Algorithms allowed networks to adjust internal weights and improve over time. In the 1990s, IBM's Deep Blue famously defeated world chess champion Garry Kasparov. It was a watershed moment. Though Deep Blue relied more on brute force calculation than true intelligence, it showed that machines could surpass humans at structured, logic-heavy tasks. Meanwhile, the rise of the internet generated an explosion of data, fertile ground for training AI. In fields like image recognition, natural language processing, and speed recognition, machine learning began to outperform traditional techniques. The 2010s marked the true dawn of modern AI, however, fueled by a subfield called deep learning. Deep learning uses multi-layered neural networks to process data mimicking the visual cortex of the human brain. It excels at identifying complex patterns in massive datasets. In 2012, the AlexNet model stunned the tech world by achieving unprecedented accuracy in the ImageNet competition, correctly identifying thousands of objects in millions of images. Its success sparked an arms race in AI research and investment. Soon, deep learning-powered applications we now take for granted, such as voice assistants like Siri and Alexa, facial recognition systems, autonomous vehicles, recommendation engines on Netflix and Spotify, and real-time language translation. Companies like Google, Facebook, Amazon, and Microsoft poured billions into AI development, building massive data centers and hiring armies of researchers. In 2016, AlphaGo, developed by Google's DeepMind, defeated the world champion in the ancient board game Go. Unlike chess, Go involves intuition, spatial reasoning, and strategy far beyond brute force. AlphaGo's victory was hailed as a leap in machine reasoning and creativity. As AI entered the 2020s, a new wave began: generative artificial intelligence. These models didn't just analyze or classify data, they could create that data. Generative models, especially large language models like OpenAI's ChatGPT-3 or GPT-4, revolutionized the field. Trained on billions of words, these models could write essays, generate code, compose music, and summarize legal documents, as well as translate languages and even simulate conversation. Image generation tools could now turn text prompts into realistic or surreal visuals. AI-generated videos, voice cloning, and deepfakes push the boundaries of synthetic media. But with power came peril. AI tools are now capable of spreading misinformation, manipulating elections, and creating convincing forgeries. Deepfakes threaten truth and authenticity. Automated hiring tools risk embedding biases. Writers, artists, and educators face questions of intellectual property and originality. I myself, an author of numerous books, have been approached by some of my publishers about my books being used to train AI models. And while I don't agree with it, a lot of times I don't have a choice. Governments, academic institutions, and corporations grappled with how to regulate this unprecedented power. Discussions about AI ethics, transparency, and alignment only intensify. Could AI be made to understand human values? Should it? What is intelligence? Can a machine ever truly understand or feel? And if a program passes the Turing test, is it thinking or just mimicking thought? Hey, I'm just here for the history. I can't answer those questions. As the historian Yuval Noah Harari put it, once a machine can learn and evolve by itself, it might take decisions in ways that we cannot understand. Intelligence is decoupling from consciousness. It may know how we feel, but it will not care. Thanks for listening, and make sure you check out today's regularly scheduled episode, where I have a conversation with the Canadian YouTube sensation Brittlestar about his newest book, Lessons from Cats for Surviving Fascism. Talk to you all guys tomorrow, and have a great rest of your day.